Hello, and thank you for coming to Six School Scholars. Today, we'll be defining functions. So, a function is a set. Oh wait, no, that's wrong. A function is a relation between inputs and outputs. Whoops, it's not there. Where every input has exactly one output, one corresponding output. So one way to think about a function is that a function is kind of like a machine, I guess you could say. Function is kind of like a machine. What it does is that it takes an input x and produces a corresponding output f of x. It returns that corresponding output f of x, and that that input is basically transformed into the output by the function f. The function takes an input and transforms it through there's some process and produces a corresponding output. So let's look at, for example, the function f of x equals x squared. So yeah, x squared. So then it relates, this function in particular relates every real number x to its square, x squared. So what it does is that it takes an input x and transforms it and produces the corresponding output f of x, and that corresponding output f of x is equal to the square of the input. So this notation is read as f of x equals x squared. So in this example, if we say that input is negative 4, then the output is the square of negative 4, or 16. It transforms the input into and produces its output, x squared. So okay, so the input and corresponding output for that input of a function may be expressed as an ordered pair, where the first term is so ordered pair is ordered so that the first term is the input x, and the last term, the second term, an ordered pair, is the output f of x. So one can say that this ordered pair takes the form x f of x, and that ordered pair can be represented as a point on Cartesian coordinate plane. So here, that would look like for our function f of x equals x squared. Let's say we took, and in our example we had -4. Let's go off a smaller number, because I don't want to draw 16 dashes. Oops. Okay. F at 2 is 4. Transforms 2 into its square, 4. So that's where 2 would be. Here, 4. So that's where our point would be. We took f at -2, we would have 4. And if we were to continue to graph points on this of this equation, like so, we would be able to, we would obtain a graph of the function. And we will, for this graph, conclude that the function f of x equals x squared takes the form, takes this form. So we were able to ascertain this after graphing, let's see, 3, 6, 7 points. We graph f at 2, f at -2, f at 0, f at 1, f at -1, and f at -1.5. So, what basically happened is that this function took numbers located on, real numbers on this x plane, and transformed them into their squares on the y-axis, and then the ordered pair becomes then the graph of the function and shows and describes the behavior of the function. So another way, think about it, well, another way we must look at it. Let's say, so the domain of a function is the set of inputs that produce permissible outputs. What this means is, well, the domain is every x value that we can that we can evaluate the function at. That will beg the question, what can we not evaluate the function at? Well, for example, if we had the function 1 over x minus 4 and we want to evaluate at 4, and this function relates a variable, well, a real number x to itself minus 4, to the reciprocal of itself minus 4. we want to back to function at 4, we would get 1 over 0. And it's possible that in your mathematics careers, you have learned that we are not able to divide by 0. Division by 0 is undefined. Don't believe me? Put in a calculator and see what your answer is. Your calculator will no doubt read error, and there you go. We cannot divide anything by 0. We can't even divide 0 by 0. So, and that'll show up in later videos, the importance of that. So, anyway, we would say that that 4 is not in the domain of the function 1 over x minus 4. Not in the domain of f of x, because it does not produce a permissible output in the and the set of permissible outputs is the range. So we say that the function takes an input x and transforms it into corresponding output y. In the range. So, thank you for watching the video. Want us to make a video on a specific topic? Just leave a comment either in the comment section below or on our website at sigschooltutors.wordpress.com. And we will try to fulfill your requests as soon as we can. Thanks.